When people answer questions, they capitalize upon their rich word knowledge and common sense in addition to the question context. While recent large-size language models are good at understanding semantic meanings of the questions, they often struggle at using word knowledge for common sense reasoning. Hi, my name is Yichong Xu, and I'm a senior researcher on the knowledge and language team of Microsoft Cognitive Services research. Our team focuses on cutting-edge research and the development of the next-generation framework for knowledge and natural language processing. In particular, I focus on using knowledge for common sense reasoning and question answering. Although recent deep learning models have brought significant breakthrough in natural language understanding, they still struggle with common sense knowledge about daily human life. However, our latest model KEAR stands for Knowledgeable External Attention for Common Sense Reasoning. It can accurately answer questions that require common sense knowledge better than a human. The common sense knowledge is often absent from the question text, but is crucial for language understanding. So let's take an example question. For example, which country is Mona Lisa located? We need to know that Mona Lisa is a painting in the Louvre Museum, which is in Paris, and in turn Paris is located in France. Thus, a model must have the capability to extract and leverage external knowledge to correctly answer the question. Human parity is the latest technical breakthrough at Cognitive Services research, and the technology can be easily used across multiple applications and products that require language understanding. Today's language models are getting larger and larger, and even fine-tuning them is impossible for many researchers and practitioners. However, large models still struggle at many common language tasks, like common sense reasoning. We propose to use external knowledge to directly feed the required knowledge into a language model, which enables us to achieve great performance even with a compact model. Centric to our approach is the external attention method, which brings additional information to the model to complement the input questions. Specifically, we integrated three sources of knowledge. The first is knowledge graph attention. Here we retrieve relevant facts from ConceptNet, a knowledge graph focusing on common sense, and append the knowledge to the input. The second is dictionary attention, where we retrieve the definitions of key concepts in the questions and answers. The third is training data attention, where we find similar questions and answers in the training set to help the model reason. After we retrieve all the relevant knowledge, we simply append all of them as text after the input questions and choices, and then we use a language model to reason between the knowledge and the question. We achieved the first place on the CommonsenseQA leaderboard last December using knowledge graph attention and dictionary attention. After that, we integrated training data attention and the latest language models, including DiBERTA and Electra. These techniques enable us to achieve human parity with only small or medium-sized models. Now let me dive into these three concepts further with some examples. Suppose we are facing the following question. Where would you find magazines alongside many other printed works? And we need to choose between bookstores, markets, or doctors. In knowledge graph attention, we retrieve the entity in the question, which is magazine, the entity in the choices, and the relationship between them based on the knowledge graph. So the results will tell us that magazines can be found at bookstores and markets, but not quite at the doctors. So in this way, we rule out the doctors as an answer. Now let's look at dictionary attention. Here we retrieve the dictionary definitions of key concepts in the question and choices to help us reason. So we find that magazine is a non-academic periodical publication, often stapled. And the bookstore is a store where books are bought and sold. A market is a gathering for the buying and selling merchandise at a set time. In this way, we get to know more about the answers. Now the bookstore looks more like the correct answer since it also sells books. To get even more confident, we further use training data attention. We find relevant questions and their correct answers that exist in the training data and in other public datasets. And they can provide very useful grounds for us to reason on. Here are some of the questions we retrieve. What could you buy in a bookstore? Magazines. Where could you get maps in a bookstore? So combining the results with dictionary attention, we get to know that the bookstore is more likely the correct answer since it also sells books and maps in addition to magazines. The beauty of the external attention method is that it is super lightweight, and it won't change the overall structure of the model, yet it is extremely powerful in expanding the common sense capability of the models. The external attention technology is being applied in a variety of Microsoft research projects and products. To learn more about our work here at Azure Cognitive Services, please take a look at our latest research publication about our milestone. For a more illustrative and interactive experience, you can read our blog on external attention, as well as the demo on the right to see more examples. You can also check out our GitHub repo to easily re-implement our method and model. Thank you for taking the time to learn more about our latest work on achieving human parity on Commonsense Question Answering.
We have to actually rethink the entire AI stack.
What is reinforcement learning? Let's look at an interactive demo.
All our code is now open source.